Okay, this is for Caden and Hunter and who knows who, 5th period, I have no idea. But we are talking writing proofs. We started this on Friday? Okay. And you guys did a little bit and talking about some things. They gave you these postulates. Did I talk about postulates and the relationship those guys have? Kinda. Okay. So you have things that are called postulates. Okay. You have things that are called corollaries. They don't talk about them very much, but corollaries. Okay. We have theorems. And those are mainly the main ones, right? We have corollaries, postulates, theorems. Okay. All of these things are facts. Okay. Some of them are baby facts. Some of them are big guns, right? Okay. Like the theorems. Those are not just baby random facts. Theorems are like there was some thought put into this, okay? So these are the big bros, okay? These are the babies. And the postulates are kind of the babies too, okay? These are babies. These are baby ideas, okay? The theorems are big bros, okay? You guys know a theorem, namely like the Pythagorean theorem, right? The Pythagorean theorem was a squared plus b squared equals c squared. That's a little intricate. Like somebody actually put some thought into that, right? Like to figure out that works for right triangles always. A squared plus b squared equals c squared. Like somebody had to do that, right? Okay. Hey, we're not writing all these down, by the way. I mean, you can, but we're not going to write all of them down. So, I mean, if you want to, you can, but I'm just trying to save you time. We're not going to write every single one of them down, okay? Because, yeah, like we'll be too full. I'm just going to have you write down the important ones, okay? So postulates, theorems, corollaries, that's this stuff. And then we use these guys to, like, prove that other things are true. Like, how do we know that these two lines, like, will not cross each other? Or how do we know that two angles that are linear pair add up to 180? Like, we're proving those things and using, like, arguments to try to do that, okay? My very favorite kind of proof, and we mostly will do two-column proofs. Two-column proofs, those are my very favorite kind, like my very favorite style. Two columns, we'll have them organized like in a two-column style, but there are also other ways to write a proof, like you could do a paragraph proof. But who wants to write a paragraph, right? We're in math. Paragraph proof? I can't spell. Paragraph proof. Or there's something called a flow proof, okay? So I'll like show you what those look like, but we will, for the most part, be doing two-column proof style. Okay. In fact, on homework assignments, when they ask you for a flow proof or a paragraph proof, I'll switch the instructions and say, make me a two-column proof, because it's just easier to list out your ideas and stuff. Okay. So when you're doing a proof, it's kind of like arguing with your mom, right? Like, Mom, you should let me go do this, or Mom, you should give me $20 so I can go do this. And your mom says, like, why should I let you do that? I don't know. Maybe your mom doesn't argue with you. Maybe she just says no, right? Or maybe she just hands it to you. But if your mom argues with you, she's going to be like, well, why should I let you do that? And you're going to be like, well, and you guys do this all the time. You were just doing this a second ago. I think we should quit for the day because we only have 25 minutes left. Right. Okay, so you're building up an argument, right? I should be able to go out and do what I want this weekend because I unloaded the dishwasher. I cleaned my room. I folded the laundry. I did all of these things, right? Like, and you're listing them off. And then you're coming to a conclusion, and hopefully she lets you do what you want, right? Okay? So you're trying to prove that something is true, or trying to prove that your point is valid, okay? So you guys did a little bit of that, and you were talking about, like, these postulates right here. Okay, I'm going to go over those just briefly. These are going to be ones that we are not going to write down. I don't think there's any big guns in this one, right? Okay, so this first one says through any 2 points, there is exactly one line. So basically, if I have 2 points, I can draw one line through it. And only one line. Can you draw a second line through those 2 points? Well, you can, but it's going to be the exact same as the first line. So it's only going to be one line, right? Okay, the second one says through any 3 points, there is a plane, right? So there is a flat two-dimensional surface, that goes through those 3 points, all right? 3 points make a plane. A line has to contain at least 2 points. If you have a line, that means there was 2 points at one point that lived on that line. That was kind of a wordy thing. But anyway, there has to be 2 points to make a line, okay? The next one says a plane contains at least 3 points, which means there could be a 4th point on that plane. There could be a 5th point on that plane. On this line, there could be a 3rd point, but there has to be at least 2 in order to make a line to begin with, right? I have to have 2 points in order to make a line. I have to have 3 points to make a plane, but there could be more than that, right? Number 5 says, if 2 points lie in a plane, then the entire line containing those points lie in a plane. So here's my plane. If I have 2 dots, right, that live on that flat surface and I draw a line, does that line also live on that flat surface? Yes, that's what number 5 is saying. If 2 lines intersect, then they intersect at exactly 1 point. Okay, they can't intersect at 2 points. If they intersect at 2 points, you've got one of these situations going on, and that's not 2 lines. That's a line in a parabola. That doesn't work, right? 2 lines are going to make 1 point when they intersect, right? Okay, but then the last one says if 2 planes intersect, so if 2 flat surfaces intersect, let's see what I can do here. Does that look like 2 planes intersecting? Something like that, right? They're making a line where they intersect, right? They're intersecting to form that straight line, okay? So that's what that stuff up there is. That wasn't very important, like that wasn't very trivial. Those are just like, oh yeah, well duh, that makes sense, right? Okay, not like the Pythagorean theorem that took a little bit of thought into it, right? Okay, those are just basic random baby facts, okay? Those are not gonna be, we might use those in a proof at some point, but those aren't gonna be the big guns that we write down, okay? One of the big guns that we write down is going to be, there's my proof sheet. So you boys that are watching this, and anybody 5th period, I gave them this sheet, and this is what we're going to write all of our important ones down on, and this sheet is pink, because McKenna said use pink, okay? So sue her, sorry. It is pink, but then you won't lose it, right? It's a pink sheet, and I'll call it the pink sheet. Get the pink sheet out, okay? We'll put all of the important theorems on here that you're going to be using a lot to do proofs with. We're going to write a couple of those down today. All right, you guys did example 2 also. Did you guys get through that one? That one made sense. Yeah, you're talking always, sometimes, never to figure out whether those things are true or not. Okay, all right, so here they're talking 2-column proof. Right off to the side down here in the bottom, do you see where I'm at? We are on page 181, where it says 2-column proofs, okay? Every 2-column proof will start off this way. They will start off with a given, and then they will start off with a prove, and that is up at the top of the proof. They will say, you're given this information, here's what you're trying to show me is true, right? You're given and what you're trying to prove, and then you will start this way. You have 2 columns, and on the left is your statements, and on the right is your reasons, okay? So, given, I don't know, what are we given? Given, my friends are going out. I don't know. This is a very bad example. I should go too. Okay? My friends are going out. I should go too. This is a very bad example because we'll be doing this with math, but there's that, okay? So, every single time when you're doing a 2-column proof, you're going to start with the given part. The given always goes down first because you have to start from somewhere. So, friends are going out. Okay? And I write literally the word given down. Okay? This is how you do a 2-column proof. You start with the given and you write your reason for the given is the given, right? Then you list off all sorts of things here so that at the end you can say, I should go too. Okay? And you don't put prove next to that. There's a different reason next to that, but you don't put prove. But in the middle, the like meat and stuff that goes in the middle is like all of the things that support, you know, what should happen. Like did dishes. Okay, cleaned room. All of the evidentiary support that goes into what you're trying to prove goes like in this meat and potatoes right here. Okay? And then at the end, you put your statement in there of what you're trying to prove. Got it? That's what this looks like. So you start with a given. They will give you this information right here. What you're given, what you're trying to prove, and then you put them in this two-column style. Statements, reasons. Statements on the left, reasons on the right. You list out all your stuff. Okay? All right. Here we go. Let's do this. Example 3. Here's what it looks like. Okay? So we have our given, and we have what we're trying to prove. So they have to tell us in this diagram. In this diagram, we know that Q is the midpoint of PR. We know that. This guy is the midpoint. Okay. They want us to prove that PQ, this guy right here, is the same as QR. Is that not true? Doesn't that just make sense? Yeah? Okay. So I'm going to show you something here, and we are going to start with statements and reasons. This is our 2-column proof. We write down the given stuff first. Q is the midpoint of PR. That is given. Okay? What we're trying to prove is that PQ is congruent to QR, and that's our last step. In the middle, we're trying to prove that those two things are the same. Now, this is going to look kind of funny, and we got to know some notation stuff. You're going to be like, I don't know about this. But just give it a second, okay? Now, if Q is the midpoint, we know that this length should be the same as this length, right? PQ should be the same length as QR. So I'm going to say PQ is equal to QR, like the measure of them, the length of them. Now, why are we able to say that? Okay? Well, the reason why we're able to say that is because the definition of midpoint tells us that if it is the midpoint, then those two are equal in length. If this one's 10 inches, the other one's 10 inches. If that one is 4 centimeters, this one's 4 centimeters, right? By definition of midpoint, PQ is equal to QR in length, okay? Now, if something is equal in measure, right? If something's equal in measure, like this is the same length as this one, does that mean that this is congruent to this one? Congruent means same shape, same size. If they're equal in measure, does that mean they're congruent? Yes, okay? Now this is another funny one. What do we put for a reason here? This is definition of congruent. Okay? By definition of what it means to be congruent, if they're equal in length, then they are equal in measure. And by definition of congruent, we have those two things. Okay? That was kind of a stretch. That was kind of a weird thing, but you'll get used to using this notation. Okay? Good? Okay, we have 3 things that we're going to write down on our sheet here. Okay? Yeah, 3 things that we're going to write down on our sheet. Okay, we'll see how far we get. All right, first one. This one doesn't have a number. This one is going to be definition of midpoint. Definition of midpoint. Okay, then we're going to have definition of congruent. Okay, and that one doesn't have a number either. And then this one is going to be theorem 3.1. I abbreviate theorem as THM. You can do the same thing if you want to, or you can write out the word theorem. I don't care. And this one is the midpoint theorem. Okay, those 3. So we got an explanation and an example. I'm going to draw my picture. Yep. Should we call it XYZ?
Is it 3-1?
Yes, theorem 3.1. XYZ. I'm going to do definition of midpoint. I'm going to do midpoint theorem at the same time. X, Y, Z. Because we're going to talk about what the difference between those two is. There's a slight difference between them. Okay. All right. Definition of midpoint. If Y is midpoint of X, Z, then, notice that we're doing the if-then thing. We're doing a conditional statement. If this happens, then this happens, right? If Y is the midpoint of XZ, then XY is equal to YZ. Okay? In measure, those two things are exactly the same. Okay? All right. If Y is the midpoint of XZ, then XY is congruent, that's the symbol for congruent, to YZ. Okay, Now, it looks like I just said the same thing over and over again. But let me tell you what the difference is. Okay? This guy is referring to, when it's equal, this is referring to the length of them, right? The length is the same. This one is talking about the shape and the size. Same shape, same size. Okay? So slightly different, but when you're talking about a line segment, the shape and the size are going to be like determinant of the length. If the length is the same, then they're going to be the same shape and same size, right? Okay, and what bridges us between those two is the definition of congruence. So if xy is equal to yz, then xy is congruent to yz. Okay, if they're equal in measure, the measure of them, then they're the same shape and size. Does that make sense? Like there's just a very slight difference between the two. Okay? If they're equal in measure, they're going to be the same shape and same size. Beautiful. Okay? Now, that's true for line segments, right? If the two line segments have the same measure, they're going to be the same shape and same size. But we will get to a point where that's not true. So for example, let me give you, don't write this down. Let me give you two triangles right here. They're both equilateral triangles. Do you know how big the angles are of an equilateral triangle?
30, 60.
60. All of them add up to be 180, right? So this would be 60, 60, 60. This is an equilateral triangle. And 60, 60, 60. Okay? Now, those angles are the same measure, right? Those angles are equal. But are those triangles congruent to each other? No, right? So it's true up here for line segments, right? Because line segments are only one-dimensional, right? But if we're talking about like a two-dimensional shape, this triangle is not going to be the same as this one just because the angles are the same. Got it? Like one of them is bigger than the other, okay? But the angles are all 60s. I just blew it up a little bit, right? Okay, so there's kind of a difference between the two. Ish, yeah? Okay, so basically, this midpoint theorem is a combination of like slapping these two together. You put those two together and you get the midpoint theorem. We just proved that. Okay? Weird stuff. This will make sense the further we go. I promise. I don't know that you'll like it more, but it'll get better. Okay? Good, good? Let's see what we got. Yep, let's do this one. Okay. Let's go to the check. We're going to have time. You don't think so? Let's do the check. We'll have time. Okay. Here's what my diagram looks like. Okay. I have A, B, C, D, E, all the things. They're all connected. I don't know. Some pieces look like they're the same. Some people's don't. I don't know. Okay. Let's write what the given is. Okay. So talking about the given. B is the midpoint of AC. This guy's the midpoint. Okay. So if he's the midpoint, what's some things that maybe I know? AB and BC are going to be congruent, right? Or equal to each other. I guess they have that down here. If B is the midpoint of AC, then we can write down that AB is going to be equal to BC by the definition of midpoint, right? Definition of midpoint, those two pieces are going to be the same. But also, I have another piece of given information. I got to deal with both of them at the same time. I have that C is the midpoint of DE. C is the midpoint of DE from here to here. So what do I know there? If C is the middle, DC and CE are going to be equal. Okay, so comma, DC is going to be equal to CE. Those two things are the same. Okay, now, I have a third piece of given information. They give me one more piece and they say that AB is equal to CE. Do you see that? Okay, notice that they didn't all write all the given up all at once, right? They wrote two pieces of given. Okay, that information tells me this. Then they write the other piece of given. You can write them all to begin with, all up at the top if you want to, but they went ahead and gave it to us as steps, okay? I'm going to use these two pieces of given information to tell me this step, and then I'm going to deal with this given information, right? Okay, so now I have that AB is equal to CE. Okay, we are trying to prove that BC, which is this guy right here, let me go in black, BC is the same as DC. These two pieces are the same. Okay. Well, if AB, this guy and CE are the same, if these two pieces are the same, then will these two pieces be the same? Yeah, probably. Okay, let's see how we get to that though. All right, so we know from this given information that this is happening right here, right? How do I go and use these three pieces all together to get to here, right? Like I want to use these all combined together to get me this. How do I go from there to BC equals DC? Okay, I see something. Ready? I have this guy right here, okay? I know that AB is equal to BC, so can I slap BC right there in place of AB? Yeah? I know that DC is equal to CE, so can I slap DC right there? Then will I have BC equals DC? Yeah, if I plug those in. So I have, oh, they must have just done one at a time. Okay, so I'm just going to do the first one at a time. I'm just going to do this part. So I'm going to slap BC right here is equal to CE. Okay, I just plugged that first one in. BC is going to go in place of, this guy is going to like take the place of AB, right? And what's that called? Substitution, right? Substitution, right? But then they did the second set of substitution for me, and they plugged DC in here, right? They did this DC, and they put it right here to make that DC down below there. Do you see that? And now I have this statement, which is what I was trying to prove. Weird stuff. We don't like this. No, it'll get better, I promise. It will. These are not fun proofs. The fun proofs come later, I promise. And there is such a thing as fun proofs, okay? All right, we'll stop there. Don't do any homework yet, okay? Happy Monday. All right, goodbye.